4.3 is graphing two variable relationships. Maybe I'll say graphing x comma y, maybe, and lines. So technically I probably should have stuck with a title that was graphing two variable relationships, but if you're going to graph that, a two variable relationship that we're doing is always going to be a line. And to graph the line, basically find a couple points that are on the line, and then from there draw a line through it. So if you think back to, should be in yesterday's notes, so a linear equation. Okay, maybe Friday. Linear equation. So linear equation, we wrote it down before. You could write it, you could skip it. Doesn't really matter much to me. But if you have a linear equation, the key was it's going to be that word line. So all the graphs that we're doing in this section are all going to be line graphs. If you get points, they should graph into a line. So Roman numeral 1 then is graphing a line for an equation. So graphing a line for or from an equation. Now, I'm going to kind of not do what would a normal geometry teacher is going to do, and I might get in trouble for this at some point. But how many points? I wouldn't do the green, but how many points do you need to draw a line? To draw a line, you need to have how many points? 2. That if you have 2 points, something like this and this, there's only one line that's going to go through those 2 points. I've read geometry books that say it's like you need 3 points to make a line. And 3 points are probably a good idea, because if you find 3 points, those 2 green ones and this orange one, can you get a nice straight line through those 3 points? No. So then you screwed up, so try it again, and see if you get a 4th point then that's like that, then okay, it's probably going to be like that line through there. So so you need 2 points to draw a line if you're feeling risky, maybe go for 2. If you want to make sure you get it right, then you could find 3. So I'm going to say find 2 plus points and draw a line through them. Draw a line through them. So I'm going to just start with, we'll just do an example. So my example is graph y equals 3x minus 2. And by the way, I have this graph paper over here on the side. Probably seen it already, but I have a whole bunch of small graphs. Those will come in handy in your homework, or larger graph paper, and I can make more of those as well. Okay, for these, to find points in the line, typically it's going to be easiest if we put a value in for x or a value in for y. Which one's easier?
Yes.
X. Because if we put a value in for x, we can just crunch the numbers. We don't need to try to solve and do a whole bunch of backwards engineering. So I'm maybe going to pick the number 0. So if I were to put a 0 in there for x, I get 3 times 0 minus 2. So my y value then is going to be negative 2. Because I have 3 times 0 is 0. Take away 2 gives me a negative 2. Now, if I want to have an accurate line, do I want my next point to be really close to that one or kind of far away to draw an accurate straight line? Far away is going to give you a better line. So maybe another x value we could pick would be 7 is going to be like way off my graph. So maybe I'm going to go with like a 3. 3 I know fits. So I'm kind of tell you one thing then do a different. But, okay, so now if I take and put a 3 in for my x value, it's kind of right over the top. I have 3 times 3 minus 2, so 9 minus 2 is 7. So my next point then is going to be 3, 7. Good? And we could go and do like a negative value. We could put in like a, maybe less, it's kind of off on the side. If I have like a negative 3, negative 4, why not? So negative 4, ooh, that's going to be way off my graph. But negative 4 times 3 would be negative 12. Negative 12 minus 2 is negative 14. And the graph paper typically that I'm going to put on a test is going to be one of these little ones on this sheet here. So it's going to go from negative 8 to 8, negative 8 to 8. So usually that's kind of what you're working with. But okay, so if I were to take and make myself a graph here. I'm going to have to jump back and forth to get my points. So I have the point 0, negative 2. Well, as we list our points, maybe I'll write it right here. So 0, negative 2. We always list the x value first, the y value second. So I'm not sure exactly where you guys are on graphing, so I'll just throw a little bit at you. But we have our x-axis, we have our y-axis, and positive. Positive x is going to the left or right? Right, so over here we have a positive x. On the left we have a negative x. Positive, you could think vertically. You know, it's a whole lot better to be up than down, you know. So positive y is up. So if I have this point 0, negative 2, first thing is I go 0 in the x direction. So if I'm starting there at the origin, if I go side to side, I go 0, so I'm still at the origin. And then negative 2 for y means I go down 2. So that right there is my point 0, negative 2. Yes? So over 0, down 2. My next point was 3, 7. So if I have my 3, 7, kind of scribble it over here. Do that in orange. So 3 is my x value, so I'm going to go 3 to the right. So that would be 3 in the x direction right there. And then I go up 7, so 1, 2, 3, 4, 5, 6, 7. So this right there is going to be my point over 3 up 7. We okay for those? And now my third one just really isn't going to fit, because I have like about 9 squares. So down there, that negative 14 isn't going to fit. So I'm going to just try to draw a line through here, see how accurate I can be with this contraption. Ooh, that was ugly. Here's where I need to get a classroom set of rulers so I can start holding you guys to a higher standard. But something like that seem reasonable. Something like that seem reasonable. So 2 points, they're not like right next to each other like this green one and right there. And get a line through it. What I'm going to be looking for when I grade these, a lot of times the quiz, okay, I'll just move on. What I'm looking for is this. If you have 2 points, your line should cover the whole graph. So on this little piece of paper, don't draw me this little tiny short line. Draw a line that actually extends to the edges of the graph in both directions. And make sure you have the arrowheads on the end. So we're here, down at the bottom I have this arrowhead. Up at the top I have a really sloppy arrowhead. Get an arrowhead on both ends to show that the line keeps going in both directions. Good? Let's say I'm looking at my line, and this line leaves something to be desired, but this point right here looks like it's on my line. So that's going to lead me up to my next section of notes. And Roman numeral 2 then is testing points on a line, or testing points to see if they're on a line, trying to figure out how to make that short. But testing points on a line. So if we go back to our line came from that equation y equals 3x minus 2. So that blue line is supposed to be all the points that if you put in an x value, that you should find the y value of that point fits 3x minus 2. So, or for each x value, multiply it by 3, subtract 2, that'll give you the y value. So the blue line is all the points that fit. So if we want to figure out if this point here fits, that point is going to be, well, it's 1 to the left of my x-axis. So that'll be a negative 1 for my x value. And the y value is it's down 1, 2, 3, 4, 5, 6. So a negative 6 for y. You with me? So if negative 1, negative 6 is a solution to that equation, if it's on the line, we should be able to put a negative 1 in there for x, and my y value should end up being the negative 6. This is that last question on the test that I didn't count because so many people slaughtered it. So I told you it was going to be on this one for sure. But testing points on a line, to do that, basically, you put the point in the equation and see if it's equal. Basically, you're trying to see, does the x and y value work in the equation? Does it still come out that it's equal? So for that last one, our equation was we'll say y equals 3x minus 2. And if I screw up on the x and y value, let me know. The x value is negative 1, right? So, I'll go back and check it. Yep, so x value is negative 1. So, if I put that in for x, I have a 3 times negative 1 minus 2. And that should equal that y value of negative 6. And when the book does it, they put a little question mark above the equals. Kind of like, is this equal? Is it not equal? And then what I was trying to get people to do on the test was to kind of show their work and say, okay, 3 times negative 1, that's a negative 3 minus 2. Oh, this is bad. I thought it was going to work. Negative 6. So negative 6 equals negative 3 minus 2 is a negative 5. So is that point actually on the graph? No, the teacher just can't draw. So negative 1, negative 6 is not a solution to y equals 3x minus 2. Or you could say negative 1, negative 6 is not on the line y equals 3x minus 2. Good? And if we had picked one that would have worked, so we know when x is negative 1, y should be negative 5. So what really happens then is I must have curved too much, that this point here instead would be on my graph. And if I had put that point negative 1, negative 5 in, should I do that quick a second? Or you guys, can you just kind of picture that? Well, if I'd put my negative 5 in here, it would have been negative 5 is in for my y. Then when I do my negative 1 was my x value. So instead of the 3x, I have a negative 1 minus 2. I'd end up with negative 5 equals negative 3 minus 2, negative 5 equals negative 5. So once you get that, then okay, yes, now I know the point negative 1, negative 5 is a solution. It is on the line. Any questions? That's what I had planned to assign right there for the homework.